Hey everybody. Let's see, today what I was, not that, was this. Adding fractions. So here's a little bit of review. In this section we're going to be adding positive and negative fractions. And I want you to realize that the same rules we use to add fractions in 4th, 5th, and 6th grade are the same rules we're going to be using here in 7th grade as we add positive and negative fractions. So fractions with common denominators are easy. The rule is simply add or subtract the numerators. What I always like to say is, if the denominator is the same, you just add the numerators. So what we end up getting is 1 plus 4, which is 5, and that's why we get 5 sevenths. If we think about the picture, what a seventh is something broken into 7 identical pieces. So if I have 1 seventh, that would be this. And if I had 4 more sevenths, that would be this. In essence, what we're doing is just counting these up. 1, 2, 3, 4, 5 sevenths. If I have positives and negatives, well, we can think about this. I have 11ths. 8 plus negative 4 is 4, so I get 4 11ths. Basically, here's some 11ths, one thing broken into 11 pieces. Here's 8 of them. And with negative 4, I want to take away 4 of them. What am I left with? 4 11ths. All right, so does this get made a little bit trickier? Yes. What happens if we don't have numbers with the exact same denominator, or numbers with the fractions with the exact same size piece? Well, in this situation, it was kind of nice. I have the exact same denominator, so I add them up. I end up getting 6/8. However, I can simplify it. So here are 6/8, but what I can do is break each of 2 of these pieces into one piece each. So notice, I can break it like this. And so instead of 6/8, I have 3/4. Basically, when we simplify a fraction, we're just trying to make an easier picture to draw. Drawing 4 pieces is easier than drawing 8. Once again, if you like to use decomposition to simplify, 6 is 2 times 3 and 8 is 2 times 2 times 2. Do you see the same numerator and denominator? You can also get the answer that way. What if I have different denominators? Basically what I'm telling you is in this situation, here's 1/3 and here's 1/2. Notice, they're not the same size piece, and you can only add things together that are exactly the same size. So what are we doing when we get a common denominator? We're creating the same size piece. What did I do? Well, I doubled the number of pieces up here. I had 3, now I have 6. And I tripled the number of pieces down here. I had 2, now I have 6. So this becomes 2/6 because when I doubled the 3 pieces, that got me 6 pieces, and when I doubled the shaded one, that got me 2 shades. And in this situation, when I tripled the number of pieces down here, that got me 6, and when I tripled the number of pieces here, that got me 3. Now that I add them together, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and I get 5 6. So when fractions aren't the same size, they don't have the same denominator. We need to create a common denominator or the same size piece, and then we solve the problem. So in this situation, what did we do? We realized that 2 times 3 was 6, and 3 times 2 was 6. Therefore, we got the common denominator of 6, and we multiplied the bottom by 3, so we multiply the top by 3. That gets us 3 6. Multiply the bottom by 2, multiply the top by 2, and we get 2. Add them together, 5 6. All done. What if I have this one? Well, once again, here are 3/4. Here's 1/6. How are we going to get them the same size piece? Did you know it was going to be 12ths? Now that we have the exact same size piece, we can just add them up. 9/12 and 2/12, 11/12. Once again, how did we do that? I can use my multiplication chart and notice 4 times 3 is 12, 6 times 2 is 12. This is the way we learned when we were kids, parents. If I subtract, once again, all I need to do is know my multiplication facts. 8 times 1, 8 times 2, 8 times 3, and then know my multiplication facts for 4. 4 times 1 is 2, 4 times 1 is 4, 4 times 2 is 8. So notice I have a common denominator right here. Multiply that by 2, multiply that by 1. 3 minus 2 is 1/8. Now here's a new way that you may have learned in 6th grade, students. It's called decomposition, where 8 is 2 times 2 times 2, and 4 is 2 times 2. Therefore, I've got 3 2's over here and 2 2's over here. What do I need? I need a 2 on this side. Whatever I do the bottom, I have to do the top. Therefore, once again, we get 3/8 minus 2/8. And we get the exact same answer. Either way works, whichever way is easiest for you to handle. Some students like this way, some students like this way. Either way is fine. So we can use all those previous rules to help us with a problem like this. 2/9 plus -5/12. All right, so what do we do here? Well, I need a common denominator. I can know my multiplication facts and know that I've got 12 times 1, 12 times 2, and 12 times 3. When I think about 9's, 9 times 1 is 9, 9 times 2 is 18, 27, and then 36. So notice, my common denominator is going to be 36. I multiply the 12 by 3, so I multiply the top by 3 and get -15. I multiply the 9 by 4, so I multiply the 2 by 4, and I get 8. 8 plus -15, that's the information we learned last chapter. They're different. We're going to subtract these numbers. There's more negatives, and that's why the answer is going to be -736. Could you decompose it? Absolutely. Notice 9 is 3 times 3, and 12 is 2 times 2 times 3. What does this side need? This side needs a 2. What does this side need? It needs another 3. So when I multiply, notice I get the exact same thing. All right, I hope this helps. The next section will be on mixed numbers, so if you have any questions, please feel free to give me a call, and everyone have a great day.